Hi, guys. How'd you do? Well, let's talk about the relationships on 4, 5, and 6. So there's a good bit going on. Perhaps you did figure out that the measure between Q and R, you can double 95. And then you find out that the measure, again, from Q to R, right out here, is going to be 190 degrees. And then you can actually subtract um, take 360 degrees. Let me put that there. Trying to get it. If we get 360 degrees, and then we subtract the 190 degrees from that, and also subtract the 75 degrees, we see that the answer to the minor arc SQ is actually going to be 95 degrees. So, one thing to remember when you are finding some of these answers is that always to go back and double check, like take 95 and add it to 75 and then add it to 90 degrees to see if in fact you get back up to 360 degrees, which I didn't do right now. I could have an error on the video. Maybe you can find it. It's worth a homework pass. Go for it. All right, so here we go. Let's go to the number 5, and we're trying to find actually the angle that's here. Now, what I want you to do, I wanted to give you guys a shot at it, is to recognize that K going is passing through the center over to J. Now, that actually has that particular chord has a special name. It's the longest chord. It's called a diameter. Now, anytime you see these diameters, you can actually associate the fact that it cuts the circle in half. Therefore, the circle that we see here, this section right around the top is 180 degrees. So there's kind of a two-step process. We're going to start by um, taking this 100-degree arc that we see right over here. Do you see it? Right there? And subtracting from 180 to figure out, whoopsie, sorry about that. Subtracting from 180 degrees to figure out what arc KL is. So when we do that, we'll only have this particular section right over here. Now, you can't speed this up and go too fast, or you won't actually answer the question. Now, I know 180 degrees, subtract this 100 is in fact 80 degrees. However, that is not the answer to our question. So, the 80 degrees that you found is actually right here on the exterior. That's the arc. This is where the 80 degrees goes. The inside or interior, and if you guys don't mind, I know it's degrees, but I'm having trouble finding that symbol, so I'm going to leave 80 in the video. But remember it to draw that little degree symbol there. So the angle measure that we have inside here, this opening right here that they're specifically asking for, is not 80 because its center is not here or its vertex, it's actually on the circle. Therefore, the answer would be, you guessed it, 40. All right, let's take a look at another one here. And this last one, there's a whole lot of relationships going on, right? Did you figure out this one here? Well, this one kind of bounces around a good bit. I'm going to use color to try to help. So we're going to start with the fact that we have this 50-degree angle. Now, when we double this, we actually find the blue arc that's right there. So when we multiply by 2, we figure out EF is actually 100 degrees, okay? So then we're going to, and I'll keep it in blue to sort of help out with that. Well, then we turn around and I'm going to grab my drawing tool again and pick a different color, some green. If we double the 58, which is the measure of the angle F to E to D, well, then we get the inscribed where this angle actually intercepts from F to D right over here. Again, if I double the 58, it's only going to be this section from F to D. So that's going to end up being 116 degrees. Now, what do you think we're going to do? You guessed it. If we subtract these two numbers from 360 degrees, we actually find our answer. So our answer down here at the bottom would actually be 144 degrees. That is our final answer. I meant to put green up there, but I think you guys are following along. Now let's look at this next rule. It says if an inscribed angle intercepts a diameter, which we saw previously, then its measure is going to be 180 degrees. And we just used that in the last video. I want you to pause the video and give these a try. I'll do number 7, and then you try 8 and 9. So 8's going to be exactly like 7, or pretty much exactly like 7. But 9, you're going to have to use the Pythagorean theorem. So first, let me try 7. So we obviously see this little right triangle. But do you see the inscribed angle? Let me highlight it to kind of help. So if we travel from A to C right out here, and then we come back to B, that's the angle we're talking about. It is an inscribed angle because the vertex C is on the circle, and these are two chords, AC and BC, just like the definition states. Now, I do see also that this line or this chord AB is my longest chord, the diameter, because it's passing through D. Therefore, X is going to equal 90. Now, possibly again, X equals 90. Possibly the easiest way to find y would to recognize now that the triangle that's inside, or we would call it inscribed, triangle ABC that's inscribed is a right triangle. So to find out why, you could just note the complementary relationship and just do 90 minus 31. Or you could use a triangle sum theorem and say 180 degrees, subtract 90, subtract 31. Either way, what are you getting? 59 degrees. That's right. Now I'll let you pause the video and try 8. Good luck.